All right, thanks. Yeah, so I'm Dan, this is Grant, and we work at a company called BugCrowd. And in case you haven't heard of us, we help connect the cybersecurity community with the cybersecurity marketplace so we can help you find bugs before the bad guys do. So today we're here to talk to you about how to run a successful bug bounty program. We have set up many bug bounty programs, and we have had a lot of things we've learned along the way, all kinds of things we've seen that were good, things that were bad, and so we want to share some of that with you so you can potentially consider starting one yourself. So first, I'm going to hand it over to Grant to introduce himself.
Hi, my name is Grant. My voice is kind of going out at the moment, but I think we should be good to go through this. So currently I'm a solutions architect at BugCrowd, which means I help set up bug bounty programs and help through the onboarding process to create successful bug bounty programs. Formerly, I was also an application security engineer also at BugCrowd, which means I validated vulnerabilities that came into the bug bounty programs that we manage. So I have the unique perspective of being on both sides of the field in terms of both setting up a program and also helping manage that program. Before BugCrowd, I spent a few years at White Hat Security, also as an application security engineer. And I enjoy traveling, making music, and stuff.
And I'm Dan. I'm currently a senior application security engineer. So I work on submissions. I also work on all kinds of operational processes. I work with people like Grant who set up bounties to make sure that everything runs smoothly. Before that, I worked in software security at HP, specifically on the Fortify product. So this was a lot more white box than what I'm doing now, but still a lot of the stuff applies, and it's been very interesting. And I ended up focusing on iOS, so I still have a particular love of mobile and of other kinds of device type testing. And my free time, I actually like to learn about and collect art. So bug bounty programs. How many of you are familiar with bug bounty programs? Okay, yeah, there's a few of you. It's AppSec, so that's good. What you might not be aware of is that bug bounty programs actually started a while ago. So Netscape ran the first bug bounty program in 1995 on the 2.0 version of their Navigator browser. And this is something where one of the engineers realized that there are a whole bunch of their really hardcore fans and users that were actually finding bugs and reporting them and even sometimes helping fix these bugs. And he said, wait a second, we should actually make this a thing. We should get this to be a formal thing. So they did, and it worked very well. So this is actually the original announcement from Web Archive from actually 21 years ago as of Monday. Additionally, since then, bug bounty programs have really taken off. So you can see that there were some really, really early ones like Netscape. And then, of course, there was Google and Facebook around 2010, 2011. And then since then, we've seen an interesting trend, which is that a lot of companies that are a little bit more traditional actually are starting bug bounty programs. So we have automotive manufacturers like Tesla, Fiat Chrysler, financial services, Western Union, MasterCard, just a lot of companies that are typically more conservative when it comes to security. They're actually using bug bounty programs, and they're doing so very effectively. Well, why would you want to start a bug bounty program? At first, you might be thinking, well, we don't want to just go out there and tell the world, let's, come hack me and we'll pay you money. That seems very, very scary. But actually, if you went to Casey and Jim's talk yesterday, you know that they're already out there. So actually running a bug bounty program, especially doing some interesting things like running a private program, can let you actually manage the risk of these people that are already out there. You're actually giving them a way to disclose vulnerabilities in a responsible way, and usually incentivizing good behavior in order to do so. So this gets into the main theme of a bug bounty program, which is this is you and them. It's not you versus them. You have to get the notion out of your head that you're working against these people around the world. You have to think of them as an extension of your team, essentially. These are people who are really, they do want to help you. And in working with them, you're going to establish the kind of relationship that's going to allow you to have them test in the future, and that will help a lot down the road. So who are these people? They really kind of are everyone. So this is actually a heat map that shows among our users where these people are from, and you can see they are from all over the world. But this extends to all other areas of diversity. So we have people of all ages. We have a lot of younger people, but of course we have people that are not necessarily as young. We have people who have been in AppSec for many, many years, or have been in other areas for many years, and we have people who are just learning security for the first time that are all doing this. They do have all levels of experience. As I mentioned, they could be AppSec people, could be pen testers by day and do this kind of as a moonlighting thing. But we really even get people who are just trying to use this as a way to learn security. They're also your users and non-users, and this might be kind of an interesting thing to think about, which is that perspective-wise, you have people who actually have a vested interest in making your app better because they use it all the time. They feel like if you improve things, then it's going to make their life easier and make them feel better. Additionally, you have people who are not your users who might just want the challenge and they test on other programs, and they're going to come to your program just because it's there and they're offering money for bugs, and it's a different perspective. That's very valuable. Overall, these people are passionate about security, and that's the common denominator, and that's where when you work with them, you're going to see a lot of value. So the value of crowdsourced testing really does come in because of this diversity. When you have a whole group of people who are from different backgrounds, different levels of experience, different ages, they've seen different things in life, and this is just the kind of thing that's going to lead to very interesting results that you don't get with traditional testing. That's not to say that they don't use traditional methods or methodologies. So you do have this idea of a series of steps, kind of reconnaissance, enumeration, exploitation, documentation, a lot of things you'd see with a normal pen test. But the difference is with a giant crowd of people, you can actually have them focus on individual areas such that the sum of the whole is actually far more powerful than just having one or two people using a formal methodology. So how do you go about doing this? That's what we're going to talk to you about. To give you a little bit of an outline, we're going to start with a lot of the pre-launch aspects, and this is kind of Grant's territory. He's going to talk about some of the things you need to consider when you're setting up a program. Stuff like, where do you want them to test? What's the scope? What kind of things do you want them to focus on? This could be vulnerability types. This could be particular targets, particular target types, anything like that. Then you're going to need to specify your exclusions as well. This is very important to make sure that you don't, you say up front what you don't want to see. And then setting up the environment and access to the environment is a very important part because you want it to be as easy as possible so there's very good experience for the person testing and there's not a lot of roadblocks to kind of make them discourage and go somewhere else. Now, I didn't really mention paying rewards. Well, we generally advise paying cash at BugCrowd. It tends to be a pretty good motivator. This is actually a distribution across unique paid submitters of how much money they got. And this is, you can see, a pretty big chunk of people got a lot of money from bug bounties. And this is the kind of thing where, the cash is going to be a very good motivator. Additionally, I don't know if anyone here has tried to ship a t-shirt to Egypt, but it's very hard. There's a lot of logistics. It's very expensive. It's just a very bad experience, and it's much better, honestly. Instead of swag, it's just to a reward or nominal amount of money. Researchers would like it more, and it'd just be easier for you. So before we get into some of the pre-launch stuff, I wanted to bring up kind of a very important golden rule that we like to think about, which is the boundary between where you do and don't pay for bugs. So if you touch the code, you should pay for the bug. This seems very simple, and of course, this is only security bugs, not UI bugs or non-security bugs. But if a bug has tangible security impact and you actually are making a change as a result of the report, you got value from the researcher, and that's a very important distinction. You should use that as a rough guideline for where you do and don't pay, because you won't pay for everything. Some things are accepted risks, but just keep this in mind. So now I'm going to hand it over to Grant to talk about the pre-launch.
Cool. Thanks, Dan. All right, so first, so what we're going to be doing here in the pre-launch section is we're going to be talking about setting up what we're going to call the bug bounty brief. This is typically a single-page document that contains all the information that researchers are going to need to test on your program. It's going to provide them with the scope, the focus areas, exclusions, things that Dan already touched on and that we'll go into more detail in a moment. And I just want to preface all this information with these are real things that we've learned from launching a number of bug bounty programs. So these are real questions and hopefully tips that you're able to get some value out of as well. So before we go anywhere, let's take a step back and talk about step 0. Do you have the basic resources and requirements to run a bug bounty program? At the bare minimum, that looks like at least one security professional who can dedicate a substantial portion of time towards managing this program. Ideally, this isn't going to be someone that, you don't tack this on to someone's already heavy workloads. If you don't have this person, you may need to either hire them or, hire a third party to manage your program for you. Other things to consider before setting up your program are escalation policies. What happens once the first critical vulnerability comes in? So you get a SQL injection vulnerability. How does that first, how is that escalated? And then also, how is that remediated within a timely manner? These are also things to consider prior to launching. And also, take into consideration how this affects other elements of your organization. Typically, a bug bounty program is rarely isolated to just the security team. It often affects also your PR, your marketing teams. Obviously, it affects developers, it affects program owners and people like that. So making sure that everybody is on the same page when you're going forward and creating this program. So now we're going to start building this bounty brief, this single-page document. Now, the single most important thing when building this document is the scope. The scope is what tells researchers what they're going to test. So there's three things that we've come up with in terms of to take into consideration when that'll help you create a good scope. So the first thing is leave nothing open to interpretation. So let's say we have the example of myapp.com/app. And we say, okay, this is the scope that we want everybody to test against. Now, if we take a step back and we look at it from a researcher perspective, if I'm a researcher and I look at that, am I only allowed to test on /app, or do I test all of myapp.com as well? And in either case, I'm either testing too little or possibly too much. So making sure that that possibly can't possibly be misunderstood by researchers is incredibly important in creating a good scope. In line with that, understanding the attack surface is also important. So if we go back to the myapp example, so we have myapp.com, and we say, okay, we're going to just cut off the /app, and we're just going to say myapp.com. As a researcher, when I go to start testing on your application, I log into login.myapp. The accounts are at accounts.myapp. API is api.myapp. And there's all these other subdomains. And again, you're stuck in the position of, okay, do I test on these or can I not test on these? So taking these things into consideration when building your scope is incredibly important. So spider your application, understand your application, and all the different subdomains that need to be in scope for researchers to be successful in testing on your program. Now, you could also go in the other direction, right? So that's having too narrow of a scope. We could also have too large of a scope. So you may say, okay, so, we want to include all the subdomains, which is great. So we'll do like star.domain, and all the subdomains are in scope. This is great. From a researcher perspective, it's really fun to test on a star.domain. I don't know if you've ever had that as a scope or tested as a researcher, but you can often find, weird subdomains that, have, a lot of vulnerabilities that aren't part of the main application. But for the very same reason this is great from the researcher perspective, this may not be so great from your perspective, because you may end up paying for bugs that, while important, these may not be the things that you wanted to focus on. You may have your focus on, my app, and, people are finding, these vulnerabilities on a weird staging server, and they're good vulnerabilities. But again, understanding your application and knowing all the different subdomains that are available for researchers to test on, and then building around that. So Dan's going to talk a little bit later about using researcher tools, like how researchers are actually going to go about like finding these subdomains. Are also other ways you can take into account when finding and understanding your attack surface. Finally, recognize that researchers, like any other force of nature, are going to follow the path of least resistance, right? So if we set up an iOS application and a web application, the vast majority of researchers are going to tend to focus on the web application. So that takes us into focus areas. So the researchers aren't going to know that, if 80% of your traffic goes through your mobile application and only 20% goes through your web app, researchers aren't going to know this information. So that's stuff that you want to call out to researchers. That's stuff that you need to make sure that they're aware of. And we call these focus areas. So you might want to focus on certain targets. Other things may be vulnerability types. Maybe you just deployed a new XSS filter or something to that capacity, and you want to see if researchers can break that. Call that out to researchers and make sure that, they know what you want them to test. Additionally, functionality is also another thing that we see a lot of. So if you just deployed new code to your application, or there's a new functionality that you want them to test on, again, most researchers aren't going to know that that's what you want, tested. So call it out to researchers. And again, as a researcher, this information is incredibly beneficial as well, because that's the freshest code, the most likely to have vulnerabilities. And so both parties can potentially benefit from this. So in terms of, how do we get people to test on these areas that we want people to focus on? Incentives. Dan talked about it earlier. Rewards are ultimately the way that you're going to get people to, do things that you want. So, attach bonuses or multipliers to, certain target types. So test vulnerabilities on, the mobile app are rewarded at a higher rate than those on the web application. Or, if you're able to, compromise, this XSS filter, we'll give you a lump sum. Now, just as important as talking about the focus areas or the things that you do want researchers to test on, it's equally important that we call out what we don't want researchers to test on. And the reason this is incredibly important is because if we put ourselves in the researcher's shoes, if we don't tell researchers what we don't want to find, researchers are going to submit everything. And then, the researchers spend time writing up those reports, and then you have to spend time evaluating those reports and then interacting with the researchers. So you really want to, as much as you can, call out the areas that researchers are typical to submit, and say, hey, don't submit these things. So things that you might not care about, and this is not an exhaustive list by any means, but these are some things to start thinking about when building your list of exclusions. So low impact, low hanging fruit is a really common one. The poster child for this is typically clickjacking. Do you care about clickjacking or do you not care about clickjacking? In either sense, make sure you call that out to researchers so that they're not submitting clickjacking if that's something that you don't want to see, or maybe be a little more specific and say, hey, only clickjacking with a proof of concept on a sensitive function. And so that points the researchers in the right directions, and they only create reports, or if they have a clickjacking report, it has to have a proof of concept, and it has to be demonstrated on a sensitive functionality. Other things to consider are intended functionality. This often looks like anything that could be misconstrued, like say an HTML editor, right? So a researcher is going to inject in the HTML editor somewhere that injection is going to fire, and they may consider that cross-site scripting. So take these things into account and call that out and say, hey, there's an HTML editor. That's intended functionality. That's not cross-site scripting. Other things to think about are known issues. This is a really sort of gray area. A lot of people, ideally most of your issues are fixed before you launch your program, but realistically that's not plausible. So you want to, as much as you can, let researchers know about these issues. And the reason for this is if we, again, put ourselves in the researcher's shoes. Think about if you spend a couple hours testing against an application, and then you find a pretty cool vulnerability, and then you submit this vulnerability, and you get a response back that says, hey, this is something that we found via a pen test a couple months ago. From that perspective, like, how much more are you willing to invest in testing this application? What else was found on that pen test from a couple months ago? And you could potentially spend, an infinite number of hours and not get rewarded for anything. So calling these issues out ahead of time to researchers is incredibly beneficial. And it doesn't have to be verbose. You don't have to say, oh, like all the nitty-gritty details about the vulnerabilities. But, hey, by the way, we have, this form is vulnerable to CSRF. Like, please don't submit that. Stuff like that goes a long way in showing the researchers that you really care about this program and you don't want them to waste their time submitting vulnerabilities that won't get them paid. Other things to consider are accepted risks. The most common example of this is open redirects. Sometimes open redirects are simply just part of your model or how your business works. It's part of the OWASP top 10. So, most researchers are going to say that, hey, this is a valid vulnerability. I should get compensated for this. And then you say, oh, wait, this is part of our model. If you can, get out in front of that and you can tell researchers ahead of time that, hey, please just don't submit open redirects. You don't have to go through that discussion. And then finally, do you want to reward issues based on pivoting? So say we have SQL injection. From that SQL injection, you're able to find that your passwords are insecurely hashed. That you can find some really cool things from that second layer finding, but do you want researchers to go that far? Letting researchers know how far to go or where to stop is also incredibly important for researchers so that they don't invest extra time in testing against this application or trying to find additional vulnerabilities that you may not intend to reward for. So if you do or don't intend to reward second layer issues, make sure that you tell researchers, hey, stop as soon as you get the database version number, or maybe go as far as you can and show us everything. So those are some of the things to consider when building your list of exclusions. So now we've got, the things we care about. We've got our scope. We've told people what not to submit. Now what are they going to be testing on, right? So there's typically two options here. You have production and you have staging. Whenever possible, I generally try to direct people in the direction of testing against staging. There's a lot of advantages to this. The main ones are that if it falls over, it doesn't affect, production customers. There's no PII, hopefully, on it. And you can use things like test credit cards that you can't normally use on production. So there's a lot of benefits to testing against staging if you can set that up for researchers. But whatever you do, and we have this tweet from Pokemon Go, make sure that it can stand up to testing. More than a few times, applications have gone down because researchers are testing. Like, understand that researchers are going to throw hundreds and thousands of requests at this application. They're going to use repeater, they're going to use intruder, they're going to use scanners. Make sure that your application can stand up to this, because the reason why this is important, aside from it just not falling over and causing other problems, is that as a researcher, if you go to test on an application and the application's down, odds are you may not come back. Or if the application's really slow, again, like, how much time are you really going to spend investing on that application? Just go test something else. There's a ton of other bounty programs out there, and you want researchers to be testing on yours. So make sure it can stand up to testing. Other things to consider in this vein are contact forms. This has happened more than once. Often your contact forms go to your sales or marketing teams. So if a researcher starts aggressively testing your contact form, is that going to generate a ton of emails to them and possibly create some noise? Again, another advantage to testing on staging, because again, you can have those forms go to nowhere. But that's something to take into consideration. If the researcher's testing on a certain functionality might break something for another department, that's something to take into consideration. Also, make sure you file your pen testing requests with AWS or Heroku or whoever you're using. And also, in line with that, make sure the rest of your security operations team, kind of like we talked about earlier, is on board with this, so they're not getting woken up at 3 o'clock in the morning thinking they're actually being attacked by researchers. Another thing to note in regards to environment is that it's not, while most bug bounty programs that are publicly visible to most people, you go to bugcrowd.com/programs, most of those bounty programs are web applications. But it's not, running a bug bounty is no longer limited to just testing a web application. You can do we've had success running against, what we'll do is we'll send out like IoT devices to researchers, and they can test on those physically. We've also done, network type tests. Another thing that's really fun for researchers to do is a CTF type thing. So there's a single objective. If you can own this box, or if you can own this, or retrieve this flag, then you get a lump sum. And it's a really, clear-cut objective, and researchers just go for that. And there's a lot of different ways that you can use bug bounty programs now. So it's not just limited to testing against web applications. And then I want to talk briefly about researcher environments. This is what a shared researcher environment looks like. I don't know if that shows quite well, but it's a train wreck out the top floor of a building. It's generally not a great thing when you have, 50 researchers all testing in the same environment. Often it's something like a CMS or an admin portal or something like that. You can kind of imagine what happens. Everybody's tripping over each other's payloads. There's endless prompt boxes. Somebody starts deleting other users. And again, none of this is necessarily nefarious. But it's something to take into consideration when setting up, your environment for researchers to test again. Segregating accounts for researchers is usually far more beneficial in terms of getting researchers. So if you're the researcher, as soon as you start running into those, it doesn't create a great environment for you to test on. And again, we want researchers to have a good environment to test on. So that's the reason why the environment is important. Which kind of takes us into the idea of access. So how are researchers going to access this environment? And the bottom line is easier equals better. This is something that we kind of touched on earlier and touched on just a moment ago. You want researchers to be testing on your application. And so we want to make it easier for researchers to test on our applications. So this means providing them with the adequate resources to be successful on your program. Some people sort of adopt a sort of like completely black box perspective on, testing. Hey, we'll give you no information and see what you can do. Again, that may be what you're trying to do, and you may get results from that, but ultimately, the greatest results are going to come from when you give the researchers as much as possible to be successful on the program. And because when they're successful on your program, that's a successful bug bounty program for you. So give them things like, test credit cards, social security numbers, phone numbers, etc. And a really good way to evaluate, how you're building this is take a step back and say, hey, what I want to test on this. Like if I know nothing else about my application, if I'm just somebody and you put this in front of me and you say, hey, you can test against this, is that something that you would actively want to go test against? And if the answer is ever no, then you should probably try to make it more enticing to researchers, because again, we want researchers to be testing on our application. Finally, it's kind of in line with what I was talking about with the environment. We don't really want to share credentials. It may be tempting to just set one set of credentials up and be like, hey, all the researchers can log in and use this. But you can guess what probably happens there. The first guy logs in, he changes the password, and nobody else can access anything. And again, if you're that researcher that can't access anything, you're probably going to go test somewhere else. And you want researchers to be testing on your application, which takes us back to the core idea of all this, is that it's you and researchers. Working with the researchers will get you exponentially better results in creating a successful bug bounty program than working against them. So you want to work with the researchers.
Thanks, Grant. So now I'm going to talk a little bit about some of the post-launch concerns. Of course, the pre-launch stuff is extremely important. Something like creating a bounty brief, you want this to be really, really good before you actually launch. Most importantly, you want to match your expectations. Post-launch is all about managing expectations. The researchers, they come in and they read your bounty brief, and especially experienced researchers, they actually know what to look for on bounty briefs. They'll look for types of exclusions that are maybe not often excluded. Certain vulnerability types that are pretty serious, but maybe for some valid reason they are excluded. They look for these kinds of things, and this is what their conception of the bounty is. So they have one expectation, and if they make their first submission, which is their first point of communication with you, and you suddenly do something that's out of line with the bounty brief, things will get very messy. So you can't avoid these messes. They do happen, and ultimately the best way to do this is to kind of announce that you're going to pause your program, collect the changes you actually need to make based on the few submissions that maybe where there were issues with them. Announce you're going to restart the program at a certain time, and then just restart with the new changes and announce them. Don't ever try and just kind of ninja make some changes and we'll do it live. It's a bad idea. If you do that, because you have so many people actually looking at your program, even if you have a private crowd and it's a small group of people and it's only 20 or 30 people, 20 or 30 people will absolutely notice your very minor changes. So just keep that in mind. Things will happen, but you can deal with them. So this goes into communication. Communication is one of the most important aspects of the bounty, and once you actually get submissions, you're going to have to start talking back and forth with researchers. So this process is something where it might seem a little bit intuitive, but it is very, very important to be concise and unambiguous. A lot of researchers actually have English not as their first language. As I mentioned, we have submitters from all over the world. So you want to make sure that you're just being very clear in your communication. Researchers will ask questions about functionality. They'll ask questions about your bounty brief potentially. Just make sure that whatever you do, you're just giving them a straight answer. Don't ever try and give them some vague answer, because, as Grant mentioned, you want to make sure it can't be misinterpreted. So in line with that, additionally, you want to be pretty quick and actually predictable with your response time and your reward time. So there's kind of a life cycle of a bug. When the researcher submits it, it goes in, and you have to have your kind of first touch, your first reply. And then at some point, it will be either kind of marked as invalid, or it will be marked as accepted. And then at some point, it'll be paid if it's marked as accepted. So this process, the more predictable and the more transparent you are with the researcher, the better experience they're going to have, and the better they're going to be able to allocate their own time in terms of they have a fixed number of hours to spend testing on bug bounties, and they want to make sure they can roughly assess the value that they're going to get. So the more predictable you are, the better it's going to be for researchers, because they can know, okay, I'm going to spend 4 hours doing this. I'm likely to find this number of bugs, and this many will be valid, and it'll be this long until I'm kind of the bug's accepted and then eventually paid. So keep that in mind, because predictability is very important. So yeah, stay on top of these issues. Again, this is really a lot easier to set all of these policies and make sure you're prepared to do this before you even launch. Because fixing this stuff as you go can be trickier. But again, if you do find that you did let a bug sit for too long, just deal with it and don't worry too much about it, and just try to improve that operational process. So public disclosure often comes up in the vein of communication, and obviously, I mean, this is a very common concern among people. Their thought is, well, if we go out to the world, as I mentioned earlier, and just tell people to hack us, well, like, what happens if someone goes rogue, and what do we do? And they're going to sell it to someone, and so, again, if you actually went to Casey and Jim's talk yesterday, this is something that happens very, very rarely. And actually, while at BugCrowd, we do advise a default policy of non-disclosure. Working to do a coordinated disclosure with a researcher can be extremely valuable for both you and them. So as an example here, we have a researcher, Stefano, who found a bug on Heroku, and this wasn't a trivial bug. You can go, look at this blog post and read it. It's kind of cool. And this was account takeover. And as you can see here, Stefano said, this is the first bug I'm actually proud of finding. So this is the kind of thing where researchers love this. They like the rewards, of course, but this kind of attention is great for their resume, and it's great for all kinds of things. So this was actually on Hacker News. It went to the front page, and it was really great. And counterintuitively, it was actually very good press for Heroku because it showed how efficiently they handled this bug. They got it. They communicated the first time pretty quickly. They fixed the issue. They worked with the researcher on a timeline. They let the researcher let them review the blog post, and this worked really well. And this actually resulted in some benefits for Heroku, where people go, okay, wow, these guys are fast and they're efficient and they're professional. I want to work on that program because it's going to be good for me. This is going to be better than working on a program that is not quite as efficient. So when it comes to actually understanding how a bug bounty program affects your security posture as an organization, the best way we found to do that is to create a vulnerability rating taxonomy. So this is basically a simple document that maps vulnerability classes to certain priorities. So we created kind of a one-size-fits-all one. We use the base for most of our programs, but we actually suggest that you create your own, and we actually modify ours for individual clients because every person is different. Every company has different needs. They are in different industries. Certain vulnerabilities are more or less severe. But keeping track of this is going to do a lot of things for you. It's going to actually let you speed up your process to triage, because if you've seen something 4 or 5 times and it's rated at this severity, at least technically speaking, you can then use that as a benchmark for any time you see it in the future, and it results in just more consistent ratings, which is a better experience for the researcher. Of course, this is going to let you track your organization's security posture. So as you see more and more vulnerabilities, you're going to get to classify. You're going to start to add fewer and fewer things because you've seen so many. But that said, and on a regular basis, you should be going through this and deciding, well, is this actually still kind of a high vulnerability, or maybe it's critical now? And why might that change? Well, you could implement some kind of protection that does something, in order to mitigate a whole class of vulnerabilities. For example, Facebook has something they call the link shim, and the link shim is something that helps prevent leakage as a result of open redirects. So they don't really care as much about open redirects, and as a result, if you can find a bypass of this system that's meant to mitigate this class of vulnerabilities, that might be more valuable. So keep those things in mind as you're constantly reviewing this document and making changes to it as you go. Now, you can publish this, and researchers will be very happy if you do, because it's another level of setting expectations. This is going to be something they use to actually decide, well, what do I focus on? What's going to be treated as a critical vulnerability that's going to get me that top payout? And also, conversely, what's the stuff that's going to be paid $0? So these are the kinds of things that researchers look for. And if you put this out there, you'll find that you'll get fewer reports that are kind of $0 accepted risks. And you might end up getting more reports that are higher severity, because if you're calling those things out, researchers will allocate their time there. All in all, though, this really just does help build trust. And that goes back to making sure that in the giant sea of bug bounty programs that exist today, you have researchers coming back and testing on yours because you've built this relationship of trust with them. So I really want to talk about some of the things that you can do as a program owner that are actually kind of thinking like a researcher. So there are all kinds of things that researchers do that could be valuable for you during the setup process, or potentially even during the bounty. As I mentioned earlier, there are a ton of regular methodologies, stuff like the Web Application Hacker's Handbook or the OWASP Testing Guide. And these are formulaic ways to go about actually approaching the long process of actually formally testing an application. Researchers do actually think about these things, and as I mentioned, they end up just focusing on individual aspects of these things, but altogether they do cover quite a lot. So some of these things that'll be helpful, and I'm just going to go very briefly through some of these things. This, by the way, is some content from Jason Haddix, who's our head of trust and security. He gave a talk at DEF CON a couple of years ago about kind of the bug hunters methodology and a lot of tools and techniques that bug hunters use to do their work. So in understanding your attack surface, which Grant talked about earlier, some of the things you're going to want to do are identify some of the roads less traveled, and researchers are very, very good at this. So stuff like acquisitions. You might realize that some acquisition of yours doesn't have quite a mature security organization by the time you acquire it. And if they're going to be integrated with your team, how does that affect your bug bounty? You should come up with a policy that explicitly says when acquisitions go into scope, or otherwise say they are not in scope unless we explicitly say so. So some companies are more aggressive than others. Google has a 6-month policy, I believe, from an acquisition to going in scope. And you better believe that bug bounty hunters will set timers for exactly 6 months, and you will get reports on that if it goes into scope in that way. Other kinds of functionality changes or redesigns, stuff like obscure platforms, mobile websites, or other kind of devices. All these kinds of areas are usually less looked at than web applications and are more likely to have bugs just because the code is not reviewed quite as much. So keep these things in mind, and as you're just defining your own scope, actually take that into consideration when you do decide to do things like create incentives for certain targets and so on. Some specific tools, I like Wikipedia for acquisitions. They actually just have lots of concise lists of every acquisition by some of the larger companies with a lot of interesting details, exact dates, individual people involved, and these can be very helpful. For subdomains, this is a really big area, especially if you decide to go with kind of a star.scope program. You might leave certain things out of scope, but if you're going to do that, you should really consider running some of these tools that researchers actually use to enumerate targets, because you're going to want to leave some things out of scope if you find out that there's some interns project from 4 summers ago that has tons of vulnerabilities. That's probably not something you want tested unless you're actually using it in production for some reason. So stuff like Google Directory, Recon NG, AltDNS, these are all great tools for subdomain enumeration. Jason Haddix, he created kind of a meta script that runs like all of these at once. Pretty convenient, makes it a lot faster. But whatever you do choose to use, just do think like a researcher, because if you do have wider scopes, if you have some of these things undefined, you will get reports regarding the things that are undefined. So there's a lot more we can't really cover in this talk, but I wanted to go through a little bit of it. And next, very briefly, just wanted to show you an example of a good report. And the reason for this is that there are certain behaviors in reports that you're going to want to encourage, and they might be things that are a little bit counterintuitive. You can imagine that a really good report has lots of detail and it really dives down into something, but that's not always the case. So here, I have an example report. You probably can't read it because it's tiny and stretched and stuff, but just if you can see the rough areas, basically the biggest one is the title and the kind of the 1-sentence or 2-sentence description of the vulnerability. These are the first things that someone validating the vulnerability will look at, and actually providing kind of the class, so in this case, insecure direct object reference, and then what is being accessed insecurely, it's multiple billing API endpoints. Well, that sounds pretty bad. And that's enough information so far for me to go, okay, I now have a rough idea of how bad this is going to be. I have a range. If you read the 1-sentence description, you'll see that he talks about just kind of changing an ID, and then you can see other customers' billing information just by having an account and being a customer. Oh, that sounds really, really broken, and that does sound like an IDOR. So everything so far is very concise, and I actually already have a pretty good idea of what to expect. Now, the researcher also did provide an exact request and response. So this is something we often recommend asking for and making it kind of known that you really do want this information, because with the request and response, you can often see what code path's being hit. You can see, you can even reproduce it yourself. You can just replay the request with your own session information. Anything like that is all going to make it just much, much easier for you to understand what's going on, especially if the researcher themselves, let's say, doesn't speak English as well, and they can't explain themselves as well. And then finally, there are a set of number reproduction steps. So this is the other really huge one that we often ask researchers to do, is make sure that you order your steps and you break them down into concise bits that we can try and reproduce. That way, if we get stuck, we can actually know exactly what point we got stuck and ask for elaboration on something very, very specific. So when I get a report like this, even though it's not that full of a report, I mean, it's not tons of details and tons of other information, I actually pretty much have enough information to validate this. So keep this in mind. The best reports are not always the most verbose or the most detailed or the most complex, but just simple and including, especially request information and steps are just very, very valuable. Now, you will ultimately get reports that are not nearly this concise. You will get reports for things like clickjacking, and even if it's something that's not fully excluded, maybe it's only for sensitive actions and you're not sure if the action's sensitive, you might be kind of inclined to jump the gun and go, oh, I've seen like 6 of these reports and I don't want, this is not good, and or we copied and pasted it or something. But keep in mind that a lot of these people are actually learning, and we've found that actually conveying what's going on and making sure that the researcher understands very specifically why the report is not valid it goes a very, very long way in actually having them not submit that stuff in the future. The number of times I've actually explained how session management works in a basic web application to someone and had them go, oh, okay, that's great, thanks, and then never seen them report that again across any program is more than you'd expect. So keep in mind that these are, researchers that are any level of experience, they could be learning. So don't be too, terse with them. Try and work with them on this stuff. And even if their report seems like it might be copied and pasted, give them a chance. Don't kind of just discard anything. So I'm going to give it over to Grant to talk about some final tips.
All right. So we've covered a lot of information so far. And so we just want to touch on a few ideas really quickly as we close out. So the first is, I consider the business impact. So there's the technical impact of vulnerability, like SQL injection, right? So, but that same SQL injection vulnerability has different business impacts if it's, on a production server, or if it's on, again, some intern server that, you didn't even know existed. Same vulnerability, different business impacts. So conveying this also to researchers can be helpful. So, certain targets may have, and this sort of goes back to, when we were talking about focus areas, certain targets may have a greater business impact associated with vulnerabilities. So you might want to attach rewards to that so that researchers have that sort of expectation. And another thing to remember, sort of what we touched on earlier, remember that the person on the other end of the keyboard is ultimately a person. If you work with them, most people are understanding and they get it, like Dan talked about. Like when you work with researchers, that's when you really get, value. That guy that you go back to and you say, hey, you explain session management to him. He may not be an elite researcher at that moment, but he's far more likely to come back and test on your application. As opposed to like if you shut him down and said, oh, this is garbage, please never submit again. That's just, that's not great for getting researchers to come back. And also the researcher community is fairly tight-knit in terms of, people share their experiences. So just treat everybody, and I mean, this goes back to the golden rule of like life, just treat people like people. But it's a good thing to remember because it can be forgotten a lot of times behind a keyboard. Finally.
The link broke. The link's broken.
Oh, link's broken. Yeah, they pulled our link into the middle of the thing. That's weird. All right, so finally, I want to leave you guys on a sort of high note here with a case study. This is Canvas by Instructure. They do learning management software, and they do something that's really cool. They post all their yearly pen test reports on their website. So that link that's in the middle of our chart, you can go there and you can actually download these reports and see the vulnerabilities, and that's great. I mean, I think that's really cool. But what we can get from that is what we can see is that in 2013, they ran a pen test, and they got 1 high finding, 1 medium, 2 low. The subsequent year, in 2014, they ran a 2-week engagement with a bug bounty, a 2-week bug bounty with 25 researchers that sort of mimics the whole pen test idea. But instead of 1 or 2 pen testers, you have 25 researchers. And these 25 researchers came up with 25 high findings, 8 medium, and 16 low. And this is the exact same application. So this really just shows what Dan talked about earlier is the real value of crowdsourced testing is that you have all these different eyes. If you've done any testing yourself, you know that you'll find things other people missed, and other people will find things that you missed. And so by having more eyes on the application, we can find more things. And then we also included 2015 on here. Which, obviously the numbers are substantially diminished, but this is, again, still the same application, and just, again, 25 researchers over the course of 2 weeks, they're still finding more things. So, again, you can continue to get bug bounty programs even a year later against the same application, or value out of the bug bounty program a year later. So, in short...
So, kind of to summarize a lot of this, basically, bug bounties are super effective, and we don't necessarily recommend that bug bounties should be a replacement for penetration testing. They can be used as a great complement to this. So it is a different type of testing, but you will get very interesting results because you have that level of diversity. And this is something that is achievable as long as you have this foresight to think when you're creating your bounty brief, what am I expecting? What do I want to see? And understand the researchers will use that to set their expectations. You're going to have a really smooth time, and you're going to get great results. So that's it. Thanks.
I work at a software company that it's B2B, so I'm having a hard time convincing anybody that letting 1,000 researchers log into our relatively small user base, they're high paying, but there's only like 100 users maybe. So I'm having a hard time convincing people that that's the right idea because there's this wall of we have to log in and be a customer. So how do you address that when you're going about doing bug bounty?
So I mean, there are certain applications that have, that are used by businesses or they're used by people who already have some level of access potentially. So of course, in a scenario like this, it's great if you can spin up some kind of staging server that's a separate instance that lets you have a whole bunch of these researchers act as businesses that are logging in. That's ideal. Running that kind of thing in production, probably not the greatest idea for that specific case, unless there's a way you can do some form of segregation, in which case we've seen cases like that. You have multi-tenant applications where you can set up like a separate kind of organization within the application and then have that be like the researchers' organization. So that's a great way to do it. But yeah, there's all kinds of things you can do just to think about, okay, what is the environment we're going to test with, and how can we do this in a way where we're just not going to cause any problems? But we have certainly tested on all kinds of B2B applications where there is definitely some level of privilege required. And then when it comes to validating the submissions, you also consider the threat model. So the threat model is you are a business who has access to this, and that's kind of where you start your business impact rating.
Certain level of quality in this process. So as a client, right, so I ask you to run a program for me. What I get, I mean, in the end, if you get really good result, I'm happy, right? What if you get, pretty average result, or even pretty poor result? How can I know that you've done it? Whether the researchers have done a good job.
Cool, yeah. So the question is, how can we, ensure that we're getting good results, or basically, if the results aren't so good, what do we do? So there's all kinds of tools you can use to do this. We basically, if you're running a bounty and we're managing it, then we're looking at all the submissions and only passing valid stuff to you. It's already rated at a priority level. But if you're managing it yourself too, even if you have someone else who's doing that kind of first level and they're passing along certain things to you, maybe you're not getting enough submissions. And in that case, we would look at adjusting the bounty. So we'd look at your bounty brief and say, maybe your scope is really, really narrow, or maybe it's not even that narrow, but it's actually the way it's conveyed is just kind of ambiguous, and it could be made more clear so it's clear that it's not as narrow as researchers think it is. So we'll ask questions like that. We'll get researchers' feedback. Maybe the rewards can be changed. So I remember cases where we had a reward range that was, pretty conservative, kind of what we start off at, which is usually 100 to 1,500. And we weren't getting money results, but we increased the top reward to 5,000, and suddenly there were lots of submissions. So researchers kind of have to make this cost-benefit decision, and some of them maybe won't test if the top reward isn't high enough, but we can always adjust those variables to make sure that we're getting better results.
In the company that did the pen test different experience for their employees, and what was the time range for the bug bounty?
In terms of time range, I believe they were both 2-week engagements. Regarding the other specifics on the pen test, I don't actually have that information, but you can go download the actual pen test report. Like, it's from the company that they used. So I imagine that you should be able to gain a lot of that information from that report. I don't know the exact cost of it or any of those other specifics, but I'd imagine that you should be able to get a lot of that information from that report.
So
You know?
you use the term researcher, not pen tested. What's behind the way? Is it as a way of laboring the business, or there's something you are implying that you use more of the researchers in front of university students?
No, I mean, we have researchers who have very diverse backgrounds. I mentioned, I mean, a lot of them are sort of like in the 18 to 29 range, but we have people who are outside of that range. There's different levels of experience. We usually refer to them as researchers or bug bounty hunters, but they have all different levels of experience, even within bug bounties themselves. We keep track of stuff like how accurate they are, so you can see like how many submissions are going to be valid versus invalid for individual people. They have, they can create profiles and stuff like that. So there's some level of like measurement of their performance within at least our ecosystem, and other people have their own ecosystem and stuff like that. But yeah, these really are just people, and some of our people are, we have elite people who are just really, really amazing at what they do. We have people who are also really, really strong in that we invite to private programs, stuff like that. But yeah, the answer is really they are just everyone. There's no necessary boundary between like we only looking at AppSec people or something like that.
It sounds like what you're running is almost like a marketplace, right? So your resource, do you have scoring system that if I come to you and I want you to run the program for me, and then I want to pick the 4-star or 5-star kind of resource to cover that?
No, well, we would pick people based on the skills required. So if you're going to test like a mobile application, we're going to pick people that we know are good at testing mobile applications. So we have an entire team of people who is very, very good at understanding exactly what people are good at and when we should and shouldn't use them. So just depending on what you want your bounty to be, that's how you make that decision. And that's kind of how you should make that decision in terms of who to attract. If you're running your own bounty and you want to test a mobile application, you should be looking for people who are good at that specifically. Anything else? All right, thanks for coming.